Welcome back to my channel. Uh, so today, today's topic is related to core data warehousing concepts. So in data warehousing, right? That's kind of a, I would say, a heart of business intelligence system, right? If you have seen my video on what is data warehouse, and I'll put a link over in the comment section. So data warehouse is heart of the any business intelligence system, because finally the output that comes out of the reporting, right, it's all stored in data warehouse, and data warehouse is all where you can say all the magic happens, right? I mean, all the calculations, all the ETL, extract, transform, load process happens, and this is where and the data design has to be um, extremely careful and proper when you design a data warehouse, because that's the base, right? I mean, and then you can scale that base. If the base you get it wrong, then you run into a lot of issues. So you run into, probably you can run into data quality issues, you can run into performance issues, and we'll cover that part regarding performance as well today. But the point being, you need to be extremely careful when you design your data warehouse. And when you design the data warehouse, right, just don't design it keeping current requirements in perspective, but think about the future, right? I mean, tomorrow if somebody comes and asks that I want to add this table, can you make it scalable? Can you make it scalable so that it is easy to add your tables? It is easy to add columns in the tables and without affecting any performance, right? So that's what basically you need to make sure. uh, so before I start today's video, right, I request you guys to please subscribe to my channel and also like my videos. That helps me a lot and motivates me a lot, right? So to make more videos. Also in my comment section, I'll put a link to the data warehouse playlist, because whatever videos I make going forward related to data warehouse, I'll add to that playlist. If you have seen my channel and other videos before, I have added the playlist for SQL related interview questions, Amazon SQL interview questions, and any videos I make further, right, I'll add to that playlist, so it is easy for you to follow along. So let's get started. So on the data warehouse, right, whenever like if you are looking at from the interview perspective, then if you are attending the interview for data architect, or senior data architect, or data engineer, or even BI engineer, right, the question will come up on data warehouse, because it's a heart of the entire BI ecosystem. So a person will definitely evaluate your skills. Interviewer will evaluate your skills on the data warehousing concepts, like, because based on this concepts, right, they will try and gauge whether you have actually worked on the data warehouse, you know the concepts, which one can give performance issues, and whether you have a practical experience with the data warehouse or not, right? So that's what they will try and evaluate. So when it comes to data warehouse, right, so there are two major schemas, so two types of schema. One is a star schema and another is a snowflake schema. So the question also comes, can you explain the star schema and can you explain the snowflake schema, and what is the difference between them, and which one would you choose, right? I mean, which one, as a BI architect or as a senior data architect, would you choose, right? What is your option? And I'll cover that as well in this video. So let's get started. So for first model is a star schema model. So star schema is a very common form of schema. You would have seen that many projects is using star schema, because it's the kind of the model. Out of, if you ask me, out of both Snowflake and Snowflake, which one is used, star schema is used widely, and that's good for the reporting system as well, because it needs less joins, right? So it needs less joins by design, and when it comes to Snowflake schema, it needs more joins. So obviously more joins, more performance issues, less join, less performance issue, right? Simple. So that's why star schema is better if somebody has to ask you, like, give me one answer, I would say star schema. But a lot of times, it depends really upon the hybrid model. So majority of it can be star schema. Some places where you need it, it can be a Snowflake schema, and some places where the data volume is very very high, such as Amazon, right? So Amazon, if you see billions of rows, lot of data, in that kind of environment, probably creating the various data marts on top of the data warehouse, right? Single core enterprise data warehouse, you can create your data marts and kind of follow a Snowflake's design there. It's possible, right? I mean, depends, right? I mean, how the requirements, how much the data is. For the lower data volume, definitely star schema is the straightforward answer. But looking at the data, right, always the decision needs to be made. So what I'm doing is I'm going to cover star schema, Snowflake schema. I will cover the combined schema as well, right? And then we'll move on to the practical example, right? I want to explain this with a practical example, right? And if you have seen my Amazon SQL video, interview questions video, I'm going to use those tables because we have been using actually those schema, right? So we've been using Star and Snowflake combined actually. I'll get to that. So if you are interested in those videos, right, please look at my channel and I'll look at those other videos. I have the playlist as well for those videos and go through that. Okay. So in Star schema, what happens, right? So the model is like Star, right? So if you see one core fact table, and then surrounded by dimension tables, right? So so if you see the fact table is there's one fact table. So this is typical you can say retail environment, right? So where you have sales, where you keep a sales setup for a customer, which customer bought the item, you keep the order ID of the item, you keep the product ID, right, which product the customer bought, which employee is associated to the customer, and then how much is the total sales for that product, how much is the quantity of the product sold, and was there any discount given, right? So typical retail channel, right, retail data model. So if you see, there are 4 dimensions here, right? And if you see, there is only single dimension. So star schema is like that. So for each of the dimension, you don't have further normalized, right? So you have, for a time dimension, you have order ID, and you can join with order ID, and you can get year, quarter, month, everything from a time dimension. In a product, you have product ID, name, category, unit price, everything in from one table. Employee, you have title, requirement, region, everything in one table. Customer, you have customer ID, name, address, city, zip, everything in one table. So basically what is happening over here is, these dimensions are called dim table, right, dimension tables, and this is the fact table. What's the difference between fact table and dimension table, right? That's also the question that comes up a lot in interview questions. So in case of fact table, right, fact is basically, fact stores a numeric value, right, and fact stores the data at a sometimes you can have multiple fact tables. You can have, when you design a Snowflake, you might need a multiple fact table, right? The reason is because, let's say the order ID, order date here is the date format, right? So it's basically 5th January 2021, right? So that's the date format. But this sales table, you can make at a year also. So you instead of order, let's say you just want to have a yearly sales, you can make this sales table as a year at a year level. Instead of order ID, you can say order year, and then you can just join it with the year attributes, and that's going to make a Snowflake. Okay, that's going to make a Snowflake, because in Snowflake, just to give an example, Snowflake, what will happen is, for year, month, quarter, you will have separate table, right? So the design is going to look like this, this one. Okay, so if you see dim date, you see purchase date, you have date, then for month you have another table, month ID, and then for quarter you have another table. So basically you are dividing one table into multiple tables, and that's the reason why I'm saying that the joins will be more in Snowflake, right? So, but consider the data warehouse of Amazon, right? Huge volume every day, lot of transactions, lot of data, right? In that case, will it make sense to join this dimension? If, let's say, Amazon, they say, let's say, give me the last 2 years of data, okay, full data, everything, all the rows. Then what happens here is, here you are joining with order ID and you are joining with order ID. and then you are going to get year from here, right? So if you have to write a query, you will say year from time dimension, join time dimension with the sales fact, correct? In that case, imagine what will happen. This sales is getting stored at a day at a order ID level, correct? Order ID. So in one day you can have how many? You can have hundreds of thousands of order, right? I mean, it's Amazon, right? I mean, just consider US. It's going to have like hundreds of thousands, millions of records actually for a day. So multiply that by 365 days a year and into 2, right? So almost like 800 days. Imagine the volume. Your query will slow down. Definitely it will slow down. So you can't use that in that scenario. So what is the solution? Create the data mart. This is the base table. Create the data mart. Create one table for month. Create one table for quarter. Create one table for day. Day is here. So in case of day, obviously when people are analyzing days data, that's operational users usually will, and they will not select all the days, right? I mean, they want to select all the days in a month, right? Month, people can select all the months for the year, right? So month, quarter and year. You can have fact tables for each of those levels, quarter, month and year, and then you can have a dimension table, right, like it is here for quarter and month. So let's imagine that you have a fact table for a month, right? So then what you're going to do, you have the data stored at a month level and you're joining with the month. It's going to be very easy, right? Because for 1 month, for one product, you will have only one record, correct? When it comes to quarter, for one order, like one product, you're going to have only one record. So you are drastically reducing the number of records, right? So in that case, Snowflake makes more sense, correct? It makes more sense because the data rate, because in this case you obviously you have to fetch a lot of record. Your query will slow down even though the join is less. The query will slow down, right? Because it's huge data. But let's consider some data where you have let's say order, right? You have order date. So for example, some pretty tiny startup, for example, okay, which has like maybe in a month they are selling maybe in a month, let's say every day they are selling, let's say 100 products, right? So in a month they will sell probably 3000 products, right? So every day 3000 products. In a year they'll say like 36 30, even if they're selling let's say millions of orders, they have million order they had in a year. This makes more sense because you don't have much data. When you join it, even if you're trying to pull a year, it's going to pull let's say million records, which it's not going to slow down a lot. It's okay, it's fine. So so you need to really if interviewer ask you, you need to really ask like what's the data volume, right? And I'll make a decision on that. If the data volume and what's the level of reporting you're looking at, right? So be interactive with the interviewer. Just I think interviewers like it when I interview people and I challenge them and they challenge me back and asking a lot of questions and make it interactive. It makes it makes a very good impression on me, even if the candidate doesn't know all the things like in detail, right? But if they can try and explain the concept, right, and they can try and explain their framework, right, then interviewer will get very impressed. So I think in this case, right, I mean the two examples I showcased, right, one is when to use star schema and when to use Snowflake schema. So let's just jump on to the Snowflake schema. So in case of Snowflake schema, I have two examples. So one example is where sales is there and then you have customer dimension. So in this case, you see customer ID is joining with customer ID, but then for city they have another dimension, right? And here if you see, the customer has city, name, address, city in a one dimension. So if somebody tells you that, oh, pull the data for, and we have this example actually, territory, right? If you remember from the Amazon video, it's a territory ID. So here if somebody says, give me all the customers along with their city names and zip code who ordered the items in from who had the sales, let's say in the and who had the sales basically with a valid product ID, or who had the sales basically. Okay, so in that case what you will do is you will join sales table with customer table and you will join city ID with city dimension. So you created two joins. Here you created only one join because you just need to join these two table and get the ID and the city and zip from the single table, right? So it's basically normalizing, right? And then you can further normalize this. Okay, so you can say city ID, I want to create another table called city, for example country, right? So in that case what you will do, city ID you will put in a country table and then you will fetch country from there, right? You want to have a different table for country, right? So in that case, if somebody else will give me the country also, you need to have three joins. So if you normalize it at the last level, right, then it's going to slow down the performance. So while designing the Snowflake also, you need to be a little bit careful that how much normalization you are doing, right? So in this case, if you say time dimension, you have it here. So if you see this, right, I mean it's not completely Snowflake actually, if you see, because time dimension is again stored in one table, but employee, department, again they have normalized it. Product also, product category, they normalized it, right? So it's a kind of no Snowflake schema. The second example is like proper Snowflake, right? Because if you see fact sales, then you have product, then you have for product category, details, product size, product color, you have separate tables. So basically what is happening is you are creating multiple joins. So if somebody tells you give me the product which and the customer combination which had the sales along with the store ID, and then give me the product category, product details, product size, product color, you will end up joining all these tables, right? You will join this table with all these tables. So imagine you join all this customer table, you join month table, store table, city table, you will end up joining so many tables, right, for no reason, right? I mean if your data volume is you can handle, right, and better to go with star schema because it has less joins, correct? So here it's completely normalized. If you see, right, for customer you have customer ID, then for city they are showing other table, country they are showing other, like I mentioned country, right? So they are showing other table. So basically they are trying to normalize it completely, and based on the requirement you can join with the different tables, right? And so if they want all the data, right, in one query or in one report, you will end up making how many joins, like 4 plus 4 plus, you make a lot of joins, so it's going to slow down the query performance, right? And that's the reason why most of the time the star schema is preferred, because it has less joins, but sometimes you have to blend it with basically the Snowflake schema. Okay, this is kind of a combined, and finally we have a combined schema. So if you see this, right, if you see this is star schema, right? So flights ID, and then you have like airport code, you are just joining, and you have airport, city, everything, longitude, time zone, everything in one table. That's star schema. But aircraft and seats, if you see aircraft, right, and then for seats they create a table. There's no need of it this here, right? I mean for aircraft you can have seat number, right, along in the same table, right? So but sometimes they don't want to do that. Let's say they want to have it in a different table, that's why they have it like this in a different table. Here if you see tickets, it's basically you have so much of join. So let's say in this case, if somebody asks you, I want to see the flight IDs along with the booking reference number, what you will do, you'll have to join this flights fact table with a tickets table, bookings table. So you will basically make 3 joins, right? And if you were to design a star schema, you can say ticket number, and then you can have booking reference, right, and total amount in single table, right? You can do that. So it's basically based on the, so that's why I'm saying that you need to be very careful on designing. And so you need to, like as a data architect, right, and I have worked as a data architect or technical solution architect as well. So you need to, when you design the core data warehouse, right, you need to make sure that you basically completely understand the complete picture. So talk to the product owner and try and see his or her vision for next 2-3 years, right? And ask those questions, right? I mean obviously sometimes product owners also don't know what is coming up, like in 3 years, right? I mean they might have visibility for this year and next year, so probably they will be able to give you answer for one or 2 years, maximum 2 years, and based on that and based on your experience, design the data warehouse which can be scalable. So what you meant by scalable is, if tomorrow somebody comes and tell me, I have product, I have employee, I have customer, I have time dimension, and then I want to bring another dimension, right, going forward, right? I should be able to easily add it in this model. It should not happen that, oh, I add one other table and then I face performance issues or I face some other issues. Design it in the way that let's say one dimension table gets added, you just have to add one key here and you can join with that table, and then you can easily basically you can easily scale it, right? So just keep that in mind. And if interviewer asks, then also say that data warehouse design needs to be scalable so that in the future needs it can satisfy the future needs, right? And without impacting the performance, right? That's very important. So let's do one thing. Let's go to Postgres and look at the practical example, right? Because I think it's very important that we look at practical examples. So if you were to look at this, right? So if you have followed my videos for the Amazon SQL interview questions, you are familiar with this table, right? So example of star schema, right? So for example, let's say you are this is the fact table, right? So see the typical fact table. Your product SKU ID, your customer ID, your order date, order value, order ID, right, and order month. Very similar to what we saw in the design, right? So if you see customer, the customer ID is there, you simply join with customer, right? And if you see here, we have customer name, customer city, everything stored in the same table, right? So we are basically doing a star schema here. Product, same thing, we are storing product name, product brand, product market name, everything in one table. Employee, same story, employee name, employee city, employee date of birth. If we needed, we could have split this, right? We would have said employee ID and employee name, we'll keep it, we'll put city in this different table, right? So that makes it Snowflake because you are normalizing it, right? You're separating it in a different column, right? So but if you see in this case, it doesn't make sense, right? I mean, usually one employee will stay in one city at a time, right? If he moves, then that's a different thing, like they'll update it. So slowly changing dimension, that's another part of the data warehouse, and I'll cover that in a separate video, right? I mean, either you can have a history of the employees where they moved and all, or you can just update the history, like if this person moves from LA to let's say Texas, then you can just update this record and say she moved to LA, Melissa moved from LA to Texas, right, and directly Texas. So point being, if you see this, employee date of birth is also stored. So if you want to really normalize it, you can store employee date of birth also in a separate table, right? If you don't want to display it in this table, you want to just put it in a different table. And sometimes there may be a reason, okay? So let's say you don't want employee date of birth to be shown to everybody, right, in the organization. You want to give select permission on that table, but then to all the people you want to show their employer name, city name, right? That you want to do, right? But date of birth and salary is confidential information. You don't want them to show it to everybody. In that case, it makes sense to keep in a separate table, put a security around that so not everybody can see it, and that way you will be able to. That's a valid scenario, okay? That's a valid scenario because you don't want to expose the sensitive information of employees to everybody, right? So in that case, I think further normalizing it and creating a Snowflake for date of birth and salary, I think makes sense, right? Based on the requirement, it will make sense, right? So and then example of Snowflake schema, right? So customer territory. So in case of customer territory, what we've done is territory ID and customer city is in a different table, right? So you need to join territory ID with the customer table, correct? Customer city. So if and we have covered this, right? I mean, there are customer territory was there in one of the questions. So in the Amazon SQL interview, so if they are looking for customer territory, then what you need to do is you need to join with customer ID of a customer table, right? And then join it with the fact table. So if they say that, right, I want to see the sales of Arizona for XYZ customer, for customer 1, right, then you have to make a join between 3 tables. So in this case, what we did is we normalized the customer territory, right? We further expanded customer table into a different customer territory table, correct? Same is the map employee hierarchy. So here if you see map employee hierarchy, if you want to get the manager of the employee, you need to go to employee hierarchy table. So all the employee and their employee ID is joining with the fact table, but then you have only employee ID. What if you want to have, let's say, requirement is display me the employees uh, along with display me the employees, right? So here if you see there's a product ID, so there is no direct join, right, in customer sales table. So you have to go through the customer and then you have to go through the territory, right? So in this case, so employee actually would not make a star schema actually, if you ask me, right? I mean, because what happens is it will actually come in the Snowflake schema. Why? Because you see customer sales fact table, you have customer ID, you don't have employee ID here, right? So you need to join customer ID with customer territory table, right? Or yeah, customer territory table, and based on the territory ID you need to join just wait a second, okay, employee ID, you have employee name, employee city. I thought we had so I think there is no join between the customer sales fact and customer territory table, right? Customer territory, only customer is there. MAMP employee hierarchy, employee city. So I think there is no direct relation between the employee and the fact table. I think the employee and employee hierarchies, we took it in a separate separate tables just to get the data. So employee and employee manager both are actually the both if you see it's a star schema. It's not a, you can't call it a star schema model because both are actually a dimension, right? I mean, oh, this is the fact actually, employee table is a fact, so yeah, it's a star schema because you are directly joining employee with the hierarchy table, and employee is nowhere related to customer here actually, right? I thought there was a relationship somewhere between customer and employee, but that's not the case. But anyhow, point being, we did have this as a Snowflake schema, right? The customer territory is a Snowflake. These two will go in the star schema, right? So it's basically you can so from the examples, right, and from the presentation, right, I hope it is clear that what we are trying to do, right? I mean, we are basically distinguishing between the two star schema and Snowflake schema. So what we learned today, right? One is star schema, what is star schema, and what is Snowflake schema, what are the advantages of each of them, which one is better, which one is better for performance, and which one would you prefer, and whether you can make it scalable or not, right? So these all the questions, I can guarantee you, if you are data engineer position, you are applying for that position or interviewing for that, two questions out of this will definitely come for sure, because this is the core of the data warehousing, right? So definitely interviewer will try and evaluate your knowledge on this. So that's it for today, guys. I hope this this video was very useful to you guys, and you learned from this video, and your concepts are basically kind of getting clear with these videos, and I hope it will help you with the interview you're attending for any of the position I mentioned, right? Any of the company, right? This is just not restricted to Amazon, but any other company you interview for data architect, for engineer, data engineer, BI engineer, these questions will be asked. It's pretty core to the data warehousing, so just be prepared for that. All right, and I'll see you all in the next video. Thank you.